Well, stop the presses, check out what just showed up from UPS. So in here is the crank for this engine, and our friend Gary in Texas has had some time to hopefully fix that keyway. If you are new here, we are fully rebuilding a YANMAR 3GM 30 that's a couple dozen years old, and it was on the teetering edge of catastrophic failure when I picked it up. I thought it was going to be okay with just a little bit of a tune-up, but an awful ticking noise brought us here to a full teardown. Sometimes life is like that. Gary is a viewer that reached out a while ago and has offered his expert machine shop services when things come up. The crank in this engine, it had this massive problem with the keyway and the key. Somehow they got all mashed up, and that allowed the gear to play on the shaft a bit. You never want to see any movement there. That should be totally fixed and locked in position, because that's the timing of the engine. So it's a little nerve-wracking shipping the crank all the way across the country and back, but it looks like it's come up in pretty good shape here. So let's bust it open and see how it looks. All right, so far so good. The custom packaging seems to have done the trick. I suppose we won't know until we measure it all back up. And these 3D printed little shipping pads seems to have done the trick. So under here, where I have this piece of plastic holding this down, is where the repair should be. So let's take this off and find it. Now, of course, there is more than one way to fix the problem with the keyway in the crank. One would have been to just simply replace the whole thing, recycle the metal, and get a brand new part from Yanmar. And that would have been a pretty much perfect fix. All brand new journals, everything would be nice and fresh. The only problem would have been my wallet. We're looking at over $1,000 for something like that. So with Gary's offer to help fix it, it made a lot of sense to attempt a fix first. So one idea would have been to TIG weld very carefully inside the keyway, add material until you can remachine out the keyway path with an exact right dimension. What we decided to do was to open it up slightly. Gary has really nice tooling. He located the part and was able to use the original keyway and this one off of the front end of the shaft to make sure that he was in the exact right spot, and made us a slightly larger keyway. So now what we have is a custom key. This is stepped, as you can see, so it's kind of got two levels to it. One will fit right inside the gear, which, since it's hardened, is not easy to machine. That's the reason why we needed the original size. But now this fits very precisely. So we'll press the new key into the keyway. And yes, there is a distinction and a difference. I was reminded by a viewer in a previous video that this is a key and that is a keyway, and none two shall pass. They are different things. Be specific. So hope you're happy. And so hopefully those parts will slide together with no observable play. They should be almost a small press fit, maybe just tapped on lightly. And then this crank should go back into service. So let's take a look at the gears here. We've got the old one and the new one in this box. So let's try the old one first, just to see how it fits. And that old gear does have just a slight bit of play, I think just because it was widened out a little bit. So let's throw the new one on and see how it feels. Okay, that seems to fit nicely, but do you hear that? Me neither. I think we got a perfect fit here. And that is test fit complete. Now, it was recommended to me to treat the keyway just so that it won't rust. And apparently if you heat it up and then quench it in oil like WD-40, it will sort of bring a surface layer of oil to it. It doesn't change the size. If you don't get it too hot, you're not going to change the temper. And so it won't get extra hardened, because I think you want to leave the keyway metal in its sort of normal state. So I looked it up. Apparently this is 4140, and according to the heat treat expert, we can get this up to even 900 degrees Fahrenheit without problem. But we're going to aim for like 400. We're just going to let it kind of turn just light purple maybe, and then dunk it. So we're going to try and just heat this up a little bit with a propane torch, dunk it in some WD-40, and see how that looks. Here we go. Well, the first attempt looks pretty good. It was definitely turning kind of blue there. Well, it still fits. I think it did all right. Let's do the other one. Now, it's very possible that I'm doing this wrong, and I'm sure that there's somebody out there in the comments that's going to let us know. You're welcome to. This is the advice I've been given from some people I trust. Next up on the agenda, I want to take a look at the main journal bearings for the crank here. We want to check the clearances, make sure that everything is right up to spec, so we're going to have a nice, good service life here. So this is one of the original bearings, and it's actually in pretty good shape. These don't have too much wear on them. Both of them look pretty good. But I do have replacements for these, so we can replace them. But what we want to do first is just check the clearance with them as is. And for that, we're going to use some of the plastic gauge. There's other ways to do it, but this is just a nice way. You put this little piece of plastic inside the part, bolt it all up, and it squishes down, and then it tells you based on that gauge there what the clearance is. So it's a pretty nice, easy, quick way to do it. Let's give it a go. Let's take a second to thank some of the new Patreon and YouTube members that help keep this channel floating along. Now, if you're interested in some extra updates and ad-free videos, you can check out the Patreon link below or hit that join button. Now, the folks whose names are appearing on the screen go the extra mile to keep this channel working, and I couldn't do it without you. Thank you all so much. Now, back to the video. Well, very difficult to bolt that down and get to the right torque spec when you have that part trying to spin, but it looks like we've got it here, and the gauge is telling me that it's between 1.5 to 2 thousandths of an inch. It's within the spec, 1.1 to 3.4 thousandths of an inch. So we are good to go with that one. We could reuse it, still tempted to swap it out because there's a little bit of wear in there. We'll see. And now, just for fun, let's reality check this with the micrometer and bore gauge. To test this with the bore gauge, I'm just gonna go ahead and put this thing back together, clamp it up in the vise, get it torqued to spec, and then we will measure the crank journal here one more time. We've measured this a few times, and we're getting the same as we have all along, so that's good. Calibrating the dial bore gauge now to the caliper. This is a bit tricky, finicky. Maybe there's a better way to do this. You can let me know down in the comments. But I think we've got it here, and this is showing me 3 thousandths of an inch instead of the 2 to 1.5 that I got with the plastic gauge. So we're all really close, we're all within spec, so I think we can keep going. The maintenance standard, the wear limit is like 5, almost 6 thousandths of an inch here. So we're inside that window. I say we press forward. A set of bearings that I know I will be replacing are all of the ones in the big ends of the connecting rods. This is the number 1 here, and there is some wear showing on the inside of the part. It's on the part where you would expect the most force to be, so that's not a huge surprise. But we're gonna definitely refresh that bearing. And if you watched the last video, you'll know that we got some new parts from Parts for Engines, including these brand new bearing shells for all of the big end connecting rods. So that's really great. Let's get those swapped out, and then we'll test the clearances again. Why are the clearances so important? It's because the oil is all running through this engine, and you're actually using a sort of pillow of oil to protect these parts. So in the real world, there isn't actually any metal on metal contact. Everything should be just slightly supported by a thin film of oil. And that's why it's so important to do your oil changes regularly, so you have that viscosity, that thickness of the oil, little ball bearings essentially, liquid ball bearings in there, keeping everything apart. But if you have too much clearance, then the oil just escapes. It can't stay in there. Too tight and the metal touches, and then everything will seize up and overheat. Too loose, the oil gets out, you have the same problem. So you have this very, very thin window that we're aiming for. Well, let's get this one updated and see how it goes. And these little bearing shells will just pry right out. And you just want to make sure that everything is super clean in there. So I'm just going to clean that with a non-abrasive, the white Scotch-Brite. It's basically nothing. And a little bit of maybe some acetone or a spray cleaner just to wipe out any oil, make sure there's no grit in there at all. And then we'll get ready to put in these new bearings. And these are fit just so that they slightly collapse as you push them in, and just the friction holds them in. And there's that little keyway that you have to observe to make sure it locates properly. Okay, well that one looks about fresh from the factory, and now we will do the same thing on the other side. And now we'll just wiggle this onto the number 1 crank, and we are observing the correct direction of the piston, even though that's probably not super critical. This time I have elected to use a digital torque gauge. I actually picked this up last night on Amazon because as I was using one of my torque wrenches, I started to wonder if it's really properly calibrated. And I have a backup that I think is more reliable. And this agrees exactly with the more reliable one. And then the other one, unfortunately, I think needs to get recaled. And I just don't really have time to do that. So this was $30, and it looks like a pretty cool tool. It came with a calibration certificate. And so as much as you can trust that, I think it's good to go. It seems like a nice little unit though. I'll put a link to it down in the description. So this clearance now looks to me to be between 1.5 thousandths to 2 thousandths of an inch. So we're like really good on the low end of the spec. So I'll go ahead and check the rest of these. I'll do all the journals and the big ends. We'll crank all this out, pun intended, and then we'll check back in. So there you go, we've got all of the journals and the crank pins tested for the oil clearance, and they're all really good. They're on the low end of the spec now, and they all have fresh bearings. You might have noticed that I did decide there to put the new main bearing journals in that I got from Parts for Engines, so that's gonna be all fresh and new now. So all of these bearings are brand new, including the ones that are gonna go in the block. Now speaking of the block, I just got a call from the machine shop, so we're gonna head out and pick something up. Okay, here it is. The block is back. The block is back in town. So we've got a couple of things to talk about here after getting this back from the machine shop. Now, one thing that I thought was interesting was when he hot tanked it, I was expecting it to take all the paint off. I guess I don't really know how that technology works, but I was expecting it to come back totally clean metal. So a little disappointing that I have some cleaning and prep work here to do still for the painting, but it is what it is. We'll get onto that in a little bit. But it is generally really clean. He said he blew out all the passageways, tried to get anything out of there, but said the motor was really clean, were his words. We have pressed in a new bearing here for the crank. We'll get to that in a minute. He said that the bores were all in pretty good shape. They were all nice and straight, not too out around, all that kind of stuff. He was pretty impressed overall. Now, there was an interesting finding though. He found that on cylinder number 1, it was actually 1/1000th of an inch smaller than the specification in the manual for the smallest size. So it was his feeling that that piston was actually a little bit too tight, even though it was working fine. So he kind of hummed and hawed on whether or not to do anything about that and just decided why not open it up to the right size. And so you'll see here that we have honed that out to the proper size, and that cylinder now, that bore is just perfect. It is completely cylindrical, a nice crosshatch on it, and it's gonna do wonderful things when we go to put that back together. Now on 2 and 3, I'm gonna be really honest with you here and show you some stuff that I'm not super happy with, but I think it's gonna be just fine. And that is that if you look into these cylinders, you'll see what the machinist called holidays. And that's his descriptive word, which I think is actually kind of funny, for these little areas where you can see that the hone did not quite get in to remove any material. Now we're talking just fractional removal here because this was 1/1000th full removal diameter, so 1/2 thousandths of an inch on either side. None of those holidays are there, and so this little bit of difference is less than 1/2 of a thousandth of an inch. So we're just kind of splitting hairs here, and since they are all at the very top of the cylinder, even at or below the top of the ring, we kind of decided we're just gonna go with it, because the alternative here would be to bore it out to the next size up, which is 1/4 of a millimeter larger, and that would involve a bunch of new parts, and I think we'll save that. These were making really good compression as they were. I probably could have just put them all straight back in with no honing and the same rings as before, and it probably would have fired up and ran pretty well for a long time. So I think with this engine now the way that it is, we have some more life left in it, we can run it for a while, and if we ever really need to take it apart again, we can overbore it to the 1/4 millimeter larger and go from there. Well, I'm sure that some of you watching will have some opinions on this and what to do. Would you run it? Would you not run it? I'm curious to hear your thoughts. You can put those in the comments down below. I think we're gonna go for it though. And now the other thing that I wanna show you, which is something I'm not super excited about, is this bearing shell here that he pressed in on the end. And it looks to me like he put it in backwards because the hole for the oil passage does not exactly line up. And to be fair, he did show me this, he did disclose it, and we talked about it in his shop and decided that we could go with it because the hole is still substantially larger than any of the oil passageways that the crank feeds the journal through, and so on and so on. So I think we're going to be okay there, but I would have loved it if it was pressed in the other way, and I think that's probably what was supposed to happen. The funny thing is, I think that even if the bearing was flipped over, although it might have a little bit more of the hole exposed, it would still be covered partially. So that's really weird. So once again, I'm interested to hear your thoughts. I'm sure that there'll be several of you out there that are going to be screaming at your television or computer saying, what on earth are you doing with that? I have considered pushing this out and reseating it. As a perfectionist, that's definitely my first inclination, is to try to extract this and redo it or have the machine shop do it. But I do think it's going to be okay. I've seen lots of examples of bearings, even from the factory, that are offset or covering holes partially, and so I think we're going to be okay, but I don't love that, and I'm sure that a lot of you don't either. Well, let's get this thing ready for some paint, get it cleaned up. So maybe we'll get that started, and then we're going to take a look at these piston ring end gaps. While I'm getting this ready for some new paint, we're going to start with an etching primer, and I will leave the base coat on there that's stuck well, but where it's starting to flake off, I'm just going to hit it with a bit of a green Scotch-Brite, maybe a wire brush, just trying to get any of that loose edge of the paint off, so we have just good material to go back onto. And we're aiming for a good paint job here, not a show quality paint job. I know, that sounds crazy, right? The idea here will be to break off any little bits of rust scale and this loose paint chips. And then before we do start building the motor, we're gonna give this thing a really good clean with brake cleaner, lots of air, all that kind of stuff. Make sure it's super cleaned off. Even though we were able to knock off a lot of the rust scale there, we still do have some oxidized iron here that we want to take care of. And so for that, we're going to start using this OSFO. This is a bottle that I've had for a long time, but I think it should still work. And basically you just brush this on and it turns the rust, the iron oxide, into iron phosphate or something, something that's more inert, and it will accept paint well. So you just paint this on, you wait about 24 hours for it to fully kick, fully do its thing, and then you can just wipe it down, clean it with a solvent, and then paint right over it. So it's a great way to start. All right, well, let's get some of this OSFO going on the block. And in the morning, it should be ready to start prepping for paint. We probably don't need too much here. This stuff goes on pretty thin. It does sort of have this like vinegar smell as you're using it. I think it's because it's kind of acidic. It goes on really thin. It's like water, basically. And I believe this also inhibits future rust. I'm not sure. We'll see. I seem to recall someone in the comments in the last video mentioned that I think their father would put this stuff on every part after he sandblasted it. And that's probably a good idea. Treat the metal so that it's not going to rust now or later. That was a great tip. It's always cool to get tips from people in the audience. There's so much helpful stuff that comes through. Sometimes things are maybe not intended to be as helpful, but that's okay. It's all good. Making these videos is really fun for me, and I've said this tons of times, but it's getting to know people and making connections along the way that make it the best part, and that's you guys and some industry experts. Last year or 2 years ago, I met Nigel Calder at the Seattle Boat Show, which was really, really cool because I have his books here, like the Boat Owner's Mechanical and Electrical Handbook, I think it's called. That is like a must-have on any boat that's out there or anywhere because it's got everything you could ever need to know about maintaining a boat. And Nigel is a really interesting guy. You might think that this is like some sort of like science professor or something with the amount of knowledge that he has locked up in that brain and seems to be so randomly accessible at any moment. But I believe he studied like philosophy or something, kind of unrelated to, mechanical things, electrical things, at least directly, but he has just such a wealth of knowledge. And he's a really cool guy, and he's great at sharing it, and he's been writing these books, I think since the 70s, maybe earlier, I don't know. Definitely need to get them, and him and a guy named Jan have teamed up, and they have launched a program called Boat How To. And it's a program that I found a couple of years ago when I was starting to look into electrical systems. The Boat How To, when they started it, was just a electrical system planning guide. They have all kinds of online resources for specifying gauges of cables based on the length, things like that, making sure you have the right ampacity in your wires. They have recently launched a small diesel engine maintenance course, and it's a super thorough program. gives you all kinds of tips on how to maintain a little engine like this. And the reason I'm telling you this is because had I have maybe spent a bit more time maintaining this old engine that we haven't pulled out yet, I might not be here right now working on this. If you spend a lot of time with your engine, getting to know them, maintaining them, it's unlikely that you'll have a catastrophic failure. Diesel engines, these little guys, should just run forever and ever with proper maintenance, oil changes, things like that. So maybe if you invest in a good course like that from someone who really knows what they're talking about, like Nigel Calder, then you can sort of tackle some of these small engine projects on your own and avoid a giant rebuild project. As fun as this is, it's been a ton of work, as you probably have noticed if you've been watching the videos. Definitely go check out their course. I'll put a link to it in the description down below. We might see more of Nigel on the channel. He's sort of offered to maybe help with the electrical system. And if he's watching this, and now he knows he's stuck. So anyway, well, that's looking pretty good. You can already see a lot of the rusty bits have sort of turned into a darker black or gray, and that's exactly what I'm expecting to see. And I think when I come out in the morning, there'll be even more so. I think I've got all the spots, and I'm just gonna make sure I wipe off the top of the cylinder here so we don't have anything on the top where I want to get a good seal with the head. I think that looks pretty good. Hi, in case you're new here, my name is John and this boat is Antidote. For the last several videos, we've been working on a full rebuild of this YANMAR 3GM 30 motor. And if you've just found us now, you might want to check the beginning of that playlist and I'll put it right up here. Now, if you're interested in this large sailboat refit that we're doing, it's a crazy over-the-top project. I'd love it if you'd follow along and we'll put that playlist also right up here. And I think that's enough shameless self-promotion for now. Let's get back to work. Okay, next up we're gonna get this rear main seal addressed. So this little piece of steel carries the bearing that the crank rides on, and as well as the lip seal, the rear main lip seal. And this part fits into a large hole in the back of the block, and this supports the largest bearing on the crank, the rear main seal. You can kind of see the serrated or the little ridges in it. That's apparently supposed to pump the oil away from the seal or something maybe, so it doesn't leak. I don't know, I've never seen those before. Thought that was interesting. So we're gonna try and press that out and get the seal out. Now the seal shouldn't be too much of a problem with our seal puller. And then getting that bearing though, that's gonna be a little bit more tricky, and I might need to take it to the machine shop. These days when I start thinking about tooling or little things, fixtures that I need, I'm always looking at that 3D printer to see if I could make something. And so we're going to try to make some parts to press that bearing out. Will it work? I don't know. We're gonna see. Stick around and we'll find out. Strap this part down, secure it to a block of wood here so that I can apply some force to this, and then we're going to use the traditional seal puller to hopefully pull this seal out. And now it's ready to attempt to press out this shell bearing. And so on the 3D printer I've made a couple of pieces. One fits exactly inside the bearing and the other one should be the outer diameter of the shell itself. And so we'll put these on the press now and see if we can get these to move. It might be a little bit too much for a plastic printer to press one of these bearings out, but let's have some fun. Well, would you look at that? How many of you at home were watching and thinking, this guy must be crazy? If that's you, go ahead and leave a comment down below. Something like, John, I thought you'd lost your mind. And let me be the first to admit, did not think that that was going to work. So that's pretty cool. Your own little custom ASA, that's what we printed that out of, bearing pusher. And I'll use that one more time to push the new bearing back in. And that should be a little easier because I'll probably throw the new one in the freezer and maybe warm this thing up a little bit. So it should hopefully just drop right into place. So I think that's pretty cool and probably the exact right time to ask you to hit that like button for me. It really does help out the channel. Appreciate it so much. Let's keep on moving. All right, more fresh parts back from the machine shop. We have the head now, has been fully rebuilt and is just about ready to go back on the engine. There's just a couple of things. For one, this thing still has a bit of rust on it, and so we're gonna need to get it ready for paint. And the second thing is that we still have those copper washers. They call them the packings in the Yanmar manual. And they're just little copper cross washers at the very bottom of these injector bores. And they are stuck in there. So the guy at the machine shop, He recommended just using a punch to hit the copper washer and hopefully it will just sort of bend and then come right out. Made it sound very easy. Now, in practicality, it didn't quite go that way, but we have managed to break them free, and I'm just gonna kind of tell you how that went. So this might also be a little bit of a don't do what I did kind of situation. So my first attempt was to use a punch like this, and this has a sort of an aggressive point. I usually use this to mark metal before I drill it. Why I chose this one, I'm not really sure. I guess that's just what I thought I would use. I gave a couple of light taps in there, and then I started to think that how thick are these washers? And when I pulled out one of my new parts, which I should have done beforehand, I realized that these are very thin little copper washers. I don't know exactly how thin. I'm gonna guess a couple thousandths of an inch, like probably less than a millimeter. Now I wanna know. There you go, 0.53 millimeters. So they're thin little washers. And I managed to put the holes all the way through the thing. Now I did manage to get it out, and you'll see this is the end that I was looking at, and there are some clear holes all the way through that guy. And if you look on the back, you can see some dimples there. And unfortunately, when I take you to look inside the bore, and I'm really kind of annoyed and embarrassed to have to show you this, but some of those punch marks did go all the way through. And so that is a little bit humbling. And the good news is though, that when I put the new washer in, it actually covers all of those holes. So I think we're gonna be okay. But it would be great if anyone out there could learn from my mistake. And what I ended up doing was using a punch more like this. So it's got a bit more of a blunt end to it. Using the same technique, punching that kind of around the perimeter of the washer did give me a similar result where it sort of beat the washer up enough to a point where I could put a screwdriver in there and wedge it out. And these ones, you can see they didn't really transfer any marks through to the back, and the bores in there look good. So number 2 and 3 look great. Number 1, it looks like a hack was in there. And in this case, that was me. So other than that, this thing looks great. We've got all new springs, new valves, and he's cut the seats and checked all the measurements. So these things look super clean, ready for service. He also, I think, took and decked this about 4 thousandths of an inch, he said, just to get it nice and flat and clean. And so that should be also just fine. We'll move this aside to get ready for paint and on to something else. Welcome back to another day here in the shop, and the block has dried up nicely. The OSFO has really cured up. It's looking good. So this is pretty much ready for paint. And now we are getting dangerously close to being able to put this motor back together. But first, a couple more quick things. So the piston and bore clearance has all been checked at the machine shop. They set all that up and they got these looking really nice. So I'm feeling really good about the clearances in there. Now, since we are doing a new ring set, we're gonna have to open these up. We've already checked all the clearances in the pistons for the ring side gaps. Everything looks good there. And now we just need to put them into the block and test the end gap clearance. So the end gap, it starts to close up the ring as the cylinder heats up, and it's important that they get close to touching because that's going to give you the most amount of efficiency for the engine. But if they get too close, then they push out into the cylinder walls and blow your engine up. So that's no good. Now, Yanmar recommends checking the ring gaps at 100 millimeters of depth, which is interesting because that's more than the stroke of the piston. But anyway, let's not ask any questions. So I printed up this little piece here. It'll set the depth of the tool, and you see I've printed it there with the bore and the depth on it. So there's no mistaking it, and it just slips really nicely down into the bores. And every time I do that, it'll put the ring in exactly perpendicular into the exact spot I want to test it. And then I'll be able to put in the feeler gauge, wiggle it in there, and test the ring end gap. So let's do one, and then once we've got that, I'll just buzz through the rest. So we'll do cylinder 1 first. That makes sense, right? This is from Parts for Engine again, and they've got all the rings labeled in descending order here, so it's hard to get them mixed up. And these also, I've noticed, have a little stamping on the ring themselves that says top. And that's on the first and second ring, because those are shaped specially to make sure that they seat properly. I think the oil ring is not as critical to get up or down, and it's not stamped. So let's hope that's the case. Got a little cap of oil here. We're just gonna use that to wet down the inside of the cylinder a little bit, just smear it with fresh oil. So when we're putting this ring in, it's not gonna hopefully leave any marks. And now we'll put a little bit on the ring itself. Same idea, just a dab will do ya. And now we'll try to get this ring inside the bore here. So I'm just gonna kind of squeeze it and push it in. and then rotate it. Well, dare I say, it doesn't look exactly like the gap is totally parallel, which is something that you kind of want. But let's check the gap anyway. We're looking for 8 to 15 thousandths, or 8 to 16 almost. So I'm actually going to just take these right off of the kit here so I can access them really easily without interfering with each other. Okay, so now I got a little deck. So there we go. We've got this one testing out, and we can get the 15 thousandths feeler gauge. That is on the high end of the spec, but we're good. And now, although it is slightly tapered with a bit more gap towards the piston than the cylinder wall, I'm just going to leave it. Some of you are probably cheering at home. You do want those to be perpendicular, pardon me, you want those to be parallel, but I don't think it's worth me grinding away material, possibly introducing some problems like burrs and things when this does technically fit. We're going to leave it alone. So 1 down, 8 to go, and I'm thankful that we don't have a V8 engine here today. Let's keep going. And that has all of the rings now gapped according to the spec, and everything looks really good. And once again, the 3D printer comes through with an unconventional application for a tool to help get the job done. And that's always really fun for me. So this is just about ready to start putting the parts back into it, like for a long time. So that's exciting. But first, I want to take a look at that rear main seal one more time. All right, you'll probably remember the bearing here that we were able to push out of the rear main carrier earlier using this piece that we printed on the 3D printer. I want to try and press the bearing back in now. We'll just see how this goes using sort of the same tools, but just in a reverse order to help hold the bearing still. I think it's walking a bit. Don't love that. Seems to be settled down now. There it goes. All right, so we're gonna unbolt the plastic parts now, and hopefully that hole is all lined up. Let's take a look. As close as it's gonna get. A few tense moments pushing that bearing in as it started to wander, but we were able to correct it, and it looks like it's going to fit really well. It feels really good on the shaft here, and we will maybe bore gauge test this just to make sure the clearances are up to spec. Do that a little bit later. So now this engine is ready to put back together, finally, and that is going to be in the next video. So if you want to stick around and watch some more, you can check out this video that YouTube is recommending to you with their almighty powers, and otherwise we'll see you next time. We'll have some fun along the way. So I think it made more... Come on. It's time to go. Got dinner with some friends tonight. I'll catch you guys later. Here, it's called Plastigage. Again.